Okay, let's go. Day 5. Advent of Code 2015. Doesn't he have intern else for this? Santa needs help figuring out which strings in this text file are naughty or nice. A nice string is one with all of the following properties. It contains at least 3 vowels, A, E, I, O, U only, like A, E, I, and so on. It contains at least 1 letter that appears twice in a row, like XX, DD, and so on. It does not contain the strings A, B, C, D, P, Q, or X, Y, even if they are part of one of the other requirements. For example, this one is nice because it has at least 3 vowels, a double letter, and none of the disallowed substrings, etc., etc. How many strings are nice? And then we have a couple of strings, I guess, in our puzzle input. So we can start with this one and check if it's naughty or nice. So for each string, we could do, I would like to do first this rule to filter out whether it's nice or not. So if string contains A, B, or all the other ones. So we could do disallowed substrings. The disallowed substrings are A, B, C, D, P, Q, X, Y. Oops, comma. And if disallowed substrings any, the string contains it. If there's any, then we want to map false. So the answer is what we map here. Else, let's see. So we just map false if we find any of the disallowed strings in our string. Otherwise, we want to check if it has at least 3 vowels and 1 double letter. So we have vowels. List of A, B, E, I, O, U contains. So we have to figure out that it contains 3 distinct vowels. Maybe we can filter the chars in the string and only keep the ones that have only keep the chars that are vowels. Then we get the distinct ones. That doesn't work. Then we get the set of this. Then we have a set of chars. And then the size needs to be greater than 2. At least 3 different vowels. Has vowels. Has 3 vowels. Then we go check the last rule, which is at least 1 letter that appears twice in a row. has letter twice in a row. Maybe we could just make a little function. One string dot this boolean. So now we want to loop through the string. For each character, we check the current character. Maybe start with an empty one. So for each character, we check if c equals to car, then we have found equals false, found equals true, car equals c, and then we return found. So we start with this car and we say we have not found a letter twice in a row, and then we check the first letter. If it's equal to the current car, then we have found something that's twice in a row, but probably it's not, because currently we have empty car and then we have a new car, kind of letter like U, and then we say, okay, let's just update current car and go to the next one, and then we just loop and always compare the current one to the previous one. And then as soon as we get something like this, we should return true. We should, oops, I think I messed this up. Okay, we should return true. Otherwise, this just remains false. If we loop through the whole string and don't find anything, we just return false. Now, if has 3 vowels and has letter in a row, then we have true, and else false. And then we always map something. So we should, oh yeah, we can just map this like that. I think that's always confusing, but whatever. Let's leave it like this. And we should see the result. Let's check the result, which is gonna be a list of one boolean, which should be true, because this example is nice. And then A is nice. We can add some more examples. And then this is naughty. This is naughty. This is naughty. Okay. Aha. We get true, false, 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 and we want true, true, false, false, false. So something is wrong with one of our rules. Let's just look at AA. What does it do? I'm curious. String is AA, okay. So it doesn't evaluate here to false. Let's look what these guys are. Has 3 vowels is false. Ah, so it doesn't have to be distinct vowels in this case, because I was looking for distinct vowels. But AA is nice because it has at least 3 vowels. So we don't need this set here. Okay, and then we only have the length. So we just filter all the vowels. Oops, let's start again. And then we have true for AA. So now we have true, true, false, false, false. And then we need to sum this, I guess. No. Map to what I can do is count it. Should only count the trues because I can evaluate the Boolean expression it. So let's get the input. We get 2, 3, 6 nice strings, and that's right. Woo! Nice. Let's continue to part 2. Realizing the error of his ways, Santa has switched to a better model of determining whether a string is naughty or nice. One of the old rules apply, as they are all clearly ridiculous. No, none of the old rules apply. Now a nice string is one with all of the following properties. It contains a pair of any two letters that appears at least twice in the string without overlapping, like XY, XY. Or A, B, C, A. But not like AAA, because this overlaps, so we need 2 separate pairs, 4 characters. It contains at least one letter which repeats with exactly one letter between them, X, Y, X. Okay. So this is a variation of the repeating rule. So that should be simple to do. Has letter has at least one letter which repeats with exactly one letter between them. Let's just say repeating letter. Just ignore that there's details. And we can go and update this function a little bit. So now we store well, we always have to look at 3, so we can do second car, first car, second car. I don't know if this makes sense of something random here. If my car well, we just want to update. So first we check, is he the same one as the first car? Okay, if it is, well, and it has to be different to the second car. See? Okay, and then in each round we update. First car is second car. Second car is C. Something like this. Let's check. Well, let's check later. I think this could work. So first car, second car. We found false. Yeah, that's the same. So for each character, so first we go in and say, is this letter that we get equal to this first car? And it won't be. So we just skip and then we say first character is the second character. So then we move this up. Second character is C, so second character is a letter. Then we go in and say, okay, the second letter is the second letter equal to this underscore thing, which is now in first car? No, so we skip it and then we go, the first car is the second car. So the letter from the first letter of the string goes into here. Second letter of the string goes into here, and then we can start checking the third in the third iteration of this for loop, if my character is equal to the first character and if it differs from the second one, and then we just keep updating to the end. Okay, so that one, I think that was this rule. Let's check later if it works. And then the first rule, it contains a pair of any two letters that appears at least twice in the string without overlapping. How can we do this? We could get two letters and then check the rest of the string if it contains that. And then we get two letters and then we can check the rest of the string if it contains it. Maybe something like that. So disallowed substrings are irrelevant. Vowels as well. So let's see. We have our repeating letter. We want something like two pairs. Has two pairs. Let's just do another function maybe. String has two pairs. Returns Boolean. Okay, so now we have to check this dot for each. Maybe we just go through the indices. Each index we check this dot substring I. Say we start at 0, 2, I plus 2, I think. Substring returns the substring of this string starting at the starting ending right before end index. So if we have a pair of letters here, and then we can check any two letters. So it doesn't matter if it's the same or something. You just get two letters. You can call it two letters. Two letters. Two cars. Two cars. So if this dot substring I plus 2 and this dot size length contains two cars, then true. So we do something again like this, found equals false. If this is the thing, then found equals true. Now we do this thing where I said that we could just look the rest of the string and see if it contains two cars. So here we take these two as two cars, and then the rest of the string see if they contain the two cars, which should be the case. So let's try it out. We can just try this one actually, I'm curious. Can we see this? Okay, so we're looping through the whole indices. we can only, here we have to stop. Ooh, we can even stop earlier. Because we don't need to check these guys anymore. We need to check only until here. Like in a bigger string we need to stop here, so that's size -1, -2, -3, -4. I think this must work. Let's see. Okay, yeah, so it evaluates to true for xy, xy. And it should also evaluate for true for has repeating that, because we have x, y, x. Nice. So then we can go into these examples. Nice, nice. Naughty. Naughty. So we should have 2. Yeah, we have 2. That's what we want. Let's go back to our input. So now we have 51. So that's actually less. That's nice under these rules. So weird flag Santa, but okay. And we're done with day 5. Thanks everyone. See you next time.